So we are moving to example 4 in section 2 of chapter 15, which requires us to find the volume of a wedge-like solid that lies beneath the surface, z equal to 16 minus x squared minus y squared, and the region that we have got is bounded by the curve y that's equal to 2 square root of x and the line y equal to 4x minus 2. Let's move to see how to sketch the region that we have got and how to deal with the integration, how to find the volume that is required from us. Here I've written the example, I'm going to show you how to sketch the graph of this region that we have got, and then move to see how to find the points that are needed, how to find the double integration, the volume that is required from us. So again, for sketching the graph of this region that we have got, the first function that we have got is y that's equal to 2 square root of x. As we know, this is the graph of y that's equal to 2 square root of x. And the second graph that we have got is y that's equal to 4x minus 2. So that is, as you know, we have got the graph of x is something like that. And then 4x moves a little bit higher. 4x minus 2 moves 2 points or a little bit to the right of the x-axis. So here we will have the graph of 4x minus 2. Okay. Okay, considering what we want, the region that we want to use, it is this one. So this is the region that will be the base for the object that we want to find its volume. Here on the left side I have drawn a better picture of this one, and we are going to work on this picture that is here, the drawing that we have got here. Okay, so there are things that we have to find. The very first thing that we have to find is the points. Okay, here is one of the points that we have to deal with and we have to find. How do you find this point? As you know, and as you see, this is the intersection of the line y that is equal to 4x minus 2 with the x-axis. We find the intersection point of a line or a function with the x-axis by simply setting y equal to 0, as you know, or let me say as you remember. So we set 4x minus 2 is equal to 0 to find the x-intercept of this function. So x here is equal to what? Is equal to 1 over 2, of course simplifying this one. So this point that we have got is 0.5, that is half. Now of course this point that we have got here is 0. Okay, this is the origin. Now we are coming to find this point that we have got here to see what is it equal to. When you look at this point, you see that this is the intersection of the two functions y equal to 2 square root of x and y is equal to 4x minus 2. As you have studied previously, we can find the intersection point of two functions when we equalize them to each other. So we simply say 4x minus 2 is equal to 2 square root of x. Okay, why do we do that? To find their intersection point, which is this point that we want to find. To find this x that we have got here, I'm squaring both of the sides. Okay, so what do we get? As you know, the first one becomes 4x minus 2 all to the power of 2. So expanding this one, I get first one squared, okay, minus 2 times first one times second one plus second one square, which is 2 squared, that's equal to 4. Equals to what? Equals to 2 square root of x squared, which gives us 4x. Taking the 4x to the other side, simplifying the equation that we have got more, so I get 16x squared minus 20x plus 4. That's equal to 0, which is a quadratic equation, and we can solve it either using quadratic formula, completing square, or any other method that is convenient for you, that is easy for you. Here I'm using the factorization method for solving this one, opening brackets. And as you see here, this equation is all divisible by 4. So I'm simplifying this one to 4x squared. Okay, so that becomes 4x squared minus 5x plus 1, that's equal to 0. This gives me 4x, and we have got x minus 1. Of course, knowing the conditions of how to factorize this equation that we have got, we get that the middle part is equal to minus 5x. So here we get that from here we get x is equal to 1 over 4, or x is equal to 1. X equal to 1 over 4 gives me here. Okay, I do not want this point here, so I'm excluding this one from the solution. Okay, I'm not using this x equal to 1 over 4. But x equal to 1 gives me the point here, which is behind the half that we have got. So here the point that we have got is what? Is 1. And of course, putting that one into one of those equations that we have got gives me 2. For example, if I will put it in here, y is equal to 2 square root of 1, and this gives me 2. So this point here is 1 and 2. Okay. Okay, now we've got the required points, and we are coming to solve, or let me say find the volume of this object that we have got, in which its base is given in that drawing. Solving this one, what will I do? I will do the double integration. Okay, double integration of what? Of 16 minus x squared minus y squared. I will choose dx dy first, and then I will show you how to do dy by dx. So as we have studied previously, we know if we have got dx dy, we have to draw a horizontal line parallel to the x-axis and passing through the region that we have got. So it is entering the region in that point in which x is equal to, we have to change that equation to what? This one changes to x equal to y squared over 4. So here I get y squared over 4. And then it is leaving the region that we have got in that point, changing this one to x form. X is equal to y plus 2 over 4. So here this limit is x equal to y plus 2 over 4. We found the limits of integration of x with respect to x. It is now we have to find the limits of integration for y. For y, we are looking where the region starts and where it ends. If you look at this region that we have got here, okay, it's starting from here and it is going till there, which shows us that it's starting from here, okay, and moving till that point, which is 2. So y runs from 0 to 2. Okay. Now we know the limits of integration for x and y. Left to solve the equation, solve the integral, let me say, not the equation. So we get this one is equal to, of course, first solving the inner integral. which with respect to x it becomes 16x minus x to the power of 3 over 3 minus xy squared, running from x equal to y over 2 over 4 to x equal to y plus 2 over 4. Okay, and the dy remains here. Okay, so we did it with respect to x. Now inputting these values, let me say these limitations, into instead of the x we get another integral. Okay, I will leave this part for you because you're already familiar of how to solve these kinds of integrals. And then you're again after simplifying this expression, after solving this integral and simplifying to something else, we get another integral with respect to y. You have to again solve it with respect to y, put the limits of integration for y, and you get the integral, the volume of the object that's equal to 12.4, which is given to you in the course material. Now we are trying to solve this integration that we have got, or let me say this, finding this volume that we have got using the order of integration when it is dy by dx. Dy dx, not dy by dx, sorry. If the order of integration is dy dx, what do we have to do? We have to draw vertical lines that is passing through the region. So the region, as we know, we have got this region that is between 2 square root of x and 4x minus 2. When I'm drawing a vertical line, okay, passing through this region, it is entering this region in here and ending in here. When we are talking about drawing lines that is going through the region to find the limits of integration, wherever that we draw this line, either it is vertical or horizontal, it must enter the same place and leave in the same place. But if you look at this one, wherever we draw this vertical line from 0 to 0.5 to the yellow line that we have got, it's entering in that point and ending, getting out in the function y equal to square root of x. But when we come to the other side, R2, region 2, when we are drawing this vertical line, the places change. The entering place becomes here, and the leaving place of the region becomes that function. Since it changes when we are drawing the vertical line, so the integration will change to two parts. Okay, region 1 will be a part, and the double integration for region 2 will be different from region 1. So we cannot solve it as one integral, one double integral, I mean. We have to change this region that we have got into two separate regions, which is R1 and R2. Okay? So when we are in R1, since we are entering in that point to the R1, here y is equal to 0. So the limit of integration of the first one becomes y equal to 0. And it is leaving the region that we have got in that point, which is y equal to 2 square root of x. So I'm here writing 2 square root of x for the upper limit of dy. We have to find the limits of integration for x also. For x, we know that this region that we have got, R1, runs from 0 to 0.5. Okay? For R1, it is from 0 to 0.5. So x becomes from 0 to 0.5. Okay? Let me write this on a little bit better. So we are done with the first region. We found the limits of integration dy dx when this vertical line is entering region 1 and leaving region 1. We have to find region 2 also. We have to check with region 2 also. For region 2, the vertical line that we have got is entering in that point, which is y equal to 4x minus 2, okay, and leaving the region in that point, which is the function 2 square root of x. Okay, left with the bounds of x. For region 2, the region starts from 0.5 and ends at 1. So here x is 0.5 and the upper limit of x becomes 1. So when the order of integration for finding the volume of this wedge-like shape is dy by dx, the order is dy by dx. Instead of having one region, we will have two regions, so we have to evaluate two double integration for finding a single volume for that object that we have got. But still, when you're solving this integral with respect to y first, then with respect to x, again, you must have what? You must get the same result that we have got, which is equal to 12.4 approximately, like the previous one. So solving a dy dx or dx dy doesn't make a difference, only the limits of integration change or the result still remains the same. So that's all about 15.2. I hope you would understand when you're listening to the videos. Have a nice time.